Good morning all. Welcome you all back to the radiological equipment lecture series. So in this series we are discussing about ultrasound transducers. So here in ultrasound transducer, so far we have discussed about what is ultrasound transducer, what are all the components present in the transducer. Then we have discussed about what is the beam characteristics, how the far field and near field will be suitably selected for the various applications. So now we are going to discuss about the characteristics of ultrasound image acquisition. So for acquiring image, we need the sound to return back to the ultrasound transducer. How it happening and how the signal strength helps in acquiring the images better, we will discuss in this particular slide. So here you have constructive interferences and destructive interferences as two different titles. So in constructive interferences, you could see that the waveform which is given in the highlighted block represent two sine waves of different amplitude, but both the sine waves are in same phase, that is it start in the same angle and ends in the same angle. So when we add these together, we will have a brighter image like what you are seeing on the screen. So when these two sine waves added together, this will become large and this will become dark in color. So we will get a better resolution image or darker or better image when we have these kinds of interaction between the sound waves. And in destructive interferences, when these two consecutive waveforms are out of phase, as you see in the highlighted block, two sine waves are there, but each sine wave is starting at different angle and they are out of phase with each other. When the dark line is at its maximum amplitude, the lighter line is at its minimum amplitude. So when you add these two sine waves together, we will have a loss of signal or minimum signal together. We call that as a destructive interferences. So in imaging, always constructive interferences is preferred to have a better resolution image. So how it is happening? If both the waveforms produced from the piezoelectric crystals are in phase, then they add together to form a stronger signal. So we will get a stronger background image or output image. And if both the waves are out of phase to each other, we will have a destructive interferences. The images will be very light and not much detailed. And these are also some other reasons for the image acquisition or image formation. The first one is specular reflection when the surface is perpendicular to the direction of sound waves. You can see that it is a perfectly reflecting surface or a smooth surface and it is perpendicular to the direction of sound wave, the first diagram. So the amplitude or the signal what we receive back having greater amplitude. So the larger arrow mark indicate the direction of produced ultrasound. The smaller arrow mark which is next to the dark line is called transmission, and the smaller arrow mark which is near to the transducer side is called echo. From that echo, we are going to have the image obtained in the ultrasound equipment. That image, if the surface is smooth and perpendicular to the direction of sound waves, we can able to acquire a good amplitude of image. And coming to the second diagram, when the surface is tilted to a particular angle, when this transducer or sound waves produced hit the surface which is inclined in nature, then the ultrasound waveform or the echo what we get returned back is very few or smaller than the first case. So we will get a smaller images or small signal where the image quality of the second type is comparatively less when compared to the first one. And coming to the last option or the last case, scattering. If the transducer is going to hit a cluster of small objects or cluster of irregular objects, then we could have only a negligible amount of reflection or echo back to the transducer. So with that, we could have a artifact or noise. We call that as a speckle in ultrasound terms. So where we could not able to figure out what kind of image it is, or what kind of organ it is, or region it is, or what shape it is actually. So the acquisition of that kind of signals will lead to the noise or artifact. We call that as a speckle. So these are the three different terms of reflection, how it affect the image formation. So the same thing when you are transmitting here, you could see that incident sound wave is the sound wave which is produced from the ultrasound transducer. If the produced ultrasound is also having certain angle, for example say 30° or 40° incline towards the surface, then the reflected waveform, ultrasound waveform, will be also have certain angle of deviation with respect to the surface. This picture indicates that particular type of instinct to you. So here we have certain types of formula to calculate the incident waveform, transmitted waveform, or observed waveform, or reflected waveform over here. We call that as Snell's law. So this angle of transmission theta t is smaller than the incident angle theta I when V2 is less than V1. So V2 and V1 represent the velocity of the sound wave in that particular medium. For example, if V1 is the atmospheric surface and V2 is the organ what we are going to scan, when the sound waves started traveling from the transducer inside our body, inside our body is considered to be V2. The variation of sound wave speed is according to the organ what we are going to scan, according to the type of organ, that is bone, air, or tissues or fluids. And in atmosphere it is left open to the surrounding, that is in atmosphere the medium of transmission is air. So velocity of V1 is considered to be velocity of sound in air, and velocity of V2 is considered to be velocity of sound wave in organs. So according to that we have a formula, V2 by V1 is equal to sine of theta t by sine of theta I, angle of transmission by angle of incident. So in order to make you to clearly understand where the ultrasound propagations will be maximum, in fluid these ultrasound transducer will pass through like a light passing through a transparent sheet or glass. In tissue we will have the same kind of transmission but little less than the fluid. In bone these ultrasound waveforms are completely get absorbed and not being transmitted, and in air these ultrasound waveforms will get reflected back in different direction. So this is how the ultrasound attenuations are different with respect to the medium in which it travels. So I hope this video gave a small idea about how ultrasound images form, what is the principle behind it, how these sound waves travel in different velocities in different medium, and how it affects the image quality. Thank you all for listening.